I'm more of a software architect, but through my fairly long career, I've been working as a DBA as well, and I always kind of stuck to the back end. What occurs to me and occurred to me is that many of us in the development community don't quite appreciate what is involved in ETL, what the considerations are, and then when it comes down to implement those features or things, when we need to interface with other groups or make things happen in the enterprise, things don't go always as smoothly as we expect. So I thought, well, why don't we talk about some of the basics there and kind of learn and think about what it means for yourself as a ETL implementer and for anybody else, which naturally leads to the first question, which is what is ETL? So ETL is acronym. I hate acronyms, but saying extract, transform, load 10 times a day is kind of a tongue twister, especially for us ESL people. So yeah, ETL is for short. And ETL denotes the three major parts of the process: extract, transform, and load. Extract, where you take data from some source. I didn't say source database, I said from some source. Now you can call everything a database, you can call a file system a database, but sources might vary, might even be services. So I'll just say fetch data from the source. That's the extract portion of the show. Then transform, you take the data that you had in one place and you want to change it in some way to transform it. So you're shaping the data during that phase to fit what you want it to look like in the target database. Speaking of which, you have the load. The load part of it is to insert the transformed data into the target database. So far, so good, pretty easy. And as you can think of it, it is the ETL could be thought of as a pipeline, right? You have the E, the T, and the L, the phase of extracting something is first phase, then you transform what you extracted, then you load it into the final database. Why did I have this fancy animation here? Well, if you are looking at ETL, then you're not really describing the database and the beginning and the end. You're describing a process, an active process. And that kind of sheds light on the fact that when we're talking about ETL, we're talking about programming in a way, right? We're talking about repeating a run of a process. And when we repeat a run of a process, we need to consider not only what the program itself does, we also need to consider its environment, like where does it run? How do I know if it ran? How do I know if it ran correctly? All kinds of things like that. At its simplest form, ETL could be thought of as just as a script, right? We can all just run a little bash script to read a CSV file and maybe shove it into a database by using some kind of utility that the database provides. Maybe something like BCP if you're using SQL Server and some batch file. That's just a script, and it can embody the whole thing in essence, right? It can read a CSV file, that's extract, E. It can transform, namely pick a few columns or things like that, maybe exercise a little select. And it can load, it pushes that data into the target database. A little more controlled, you might have a system that pulls database in. So some database engines include within them the ability to load files from disk, to read some things from some services or from other database, maybe using linked databases. That wasn't a cough. I'm just trying to discourage you from ever using linked databases. So we might want to have some kind of control, the little robot thing here that talks to some source database and pushes it into the database in situ resident, running this whole process within the database engine. That has some implications. Obviously, it requires that the database engine supports such processes and supports you running processes that can touch the outside and also the insides, and also run some programming such as stored procedures, which seems natural to those of us who are using, the SQL servers, the oracles, and things like that to support stored procedures and server-side coding. But in other databases, big data type stuff, MongoDBs, Hadoops, and things like that, there's no really native running within the database engine. You are doing process control to have external processes. And indeed, things like SSIS and packages that do ETL are independent program altogether. This could also come as a push from a source database pushing to the target database. And philosophically, it's very similar. And philosophically, it suffers from the same issues of having to adhere or to leverage features of the database engine itself, which means you need that. I said philosophically, I want to belabor that point a bit more. When you are telling the source database that it needs to push data to a foreign database, you're outside of the swim lines. You're really saying, I need to know about a foreign system. So that makes those two systems tightly coupled. It means that a source database, your OLTP or what have you, will have to know about the target database somehow, right? It hosts code and procedures that know about something outside that they have no control over. So that to me is a little bit of a violation of the scope of what a database engine really wants to do. Databases are extremely good at I/O, at serving queries, at running workloads that are internal, at doing joins if it's that kind of database, at using indexing to do things really fast, at serializing data, at keeping the data safe, at keeping data consistent. But those engines are typically not very good at marshaling other processes outside, certainly not other databases. They won't have access to the internals of the other databases. So to me, both the push and the pull are a little antithetic, are a little anti-patternish, if you will. And I would prefer somewhere in the middle, where the whole ETL really represents an activity that is external to either the source or the destination data. And this is very common out there in the wild. Most of the larger ETL programs exceed a single little script, exceed just a stored procedure or 100 stored procedures. The larger your data and your database, the larger these things become. And just having to control that process, to run it, to log it, to debug it, all of these things, you want kind of external infrastructure that is purpose-built to do that, a tool of sorts. So, Nuri, are there any tools I can have? Sure, tons of them. There's SSIS if you're in the SQL Server world. There's Informatica, one of the big 500-pound gorillas in the field. Talent, CData, Tibco, Pentaho. Airflow is an open source Apache project, which I kind of like. I haven't used it very extensively. It's kind of new to me, but I kind of like the way it is because it's both very data centric and engineered for this kind of job, yet it is very programmatic. It exposes the interfaces for the transformations and for data reach and so forth as Python modules, which I kind of like. And of course, you can write your own thing from scratch using any job engine, cron or whatever to do the activation of things on a timer and write your own shell scripts or Python or C# or Java or whatever language you like. Probably Perl, because Perl is awesome. Okay, so I just talked about ETL, right? What's missing? If I just had to think about ETL and I said, here's the process, extract, transform, load, what would come to mind as missing? Somebody? Anybody? So I claim a big part of the process that is missing is design. We can't jump into an ETL and just do the extract, the transform, the load. In fact, if your boss walks into the room and says, dude, just do it. Here, take the data from here. They need it over in the BI department or in some data warehouse. Just do it. I would say, wait. We're not just going to use the tool off the shelf, even though we have it. I'm not just going to dig in and start writing functions, even though I know how to. The most common failure is failure to understand the problem fundamentally and to design an ETL process that fits the target and the source as well as the process itself. If we just try to reach out to tools off the shelf and bang it together, we're likely to not produce excellence. How's that for a nice way to say you're going to fail? It's not going to fail absolutely on day one necessarily. It can, but it's not likely to produce excellence. Because the big picture is we have some kind of source of truth, yeah, a source database, and we have some kind of destination database that we are going to need to distill data from the sources into the destination. And that distillation is for creating a useful inference, meaning that we want to tie data that we got from a bunch of places and make it into other useful data, representing the same facts, but in a way that is useful, right? Otherwise, why did we want to take it out? There's no reason for me to just copy data out. That's backup. That's not ETL, right? So if I'm wanting to do something, I have to be purposeful. I have to be purpose-driven to figure out what are my sources of truth, what the truth is in those sources, and what useful inference is necessary. That process includes design. That process includes all of the study of the source systems, the destination systems, the speed, the time window I have, my budget, my tools available off the shelf, whether they're useful or not, and all of that. So with that in mind, let's take an example. I have some retail company. It sells stuff. Maybe it has a catalog, and the catalog contains products. So I want to sell the products, and I want to have in that destination database, that would be my destination database, would be a catalog of sorts. I will need to store information about products married to their prices, married to all kinds of other items so that I can operate my catalog operation. And as you can imagine, the catalog needs to be fed by something. Vendors make the products that go into the catalog. Even if it's the same company that makes it, there will be a different system where we describe all of the products that would end up in the catalog. So I will treat those as vendors. I will treat those as separate database. That would be my source. So we'll start really simple. We'll take a catalog offering. And in the source, I had a ID 456. It's a farm wagon. It has a model number and it has a price. And in the target database in my catalog, I need an image of that. I need to know these things. So I need some process to take it from the source to the destination, pretty much straight through. Well, almost straight through. If you notice, the price that I have from the vendor is not the price I'm going to sell it at. So there needs to be some kind of transformation that knows how to take the source price and add the markup to it. In this case, who knows what that markup is? Can I reverse engineer it from looking and seeing that it's 60? Well, I could think to myself, aha, take the original one and add 50%. Or it could be a fixed markup that my ETL process will just add 20 bucks on every product or something like that. Either way I look at it, it's some kind of a computation. I take some values, some fields from the source data sets or data set, and I perform some mathematical computation on them. So this is a very common transform. I take some stuff, I apply some straight math, not having to look up anything. It's really a very simple, low to the ground kind of a migration that I'm doing. I'm just taking some data, applying some math, and throwing that into the target. Another common transform would be normalization. Normalization, of course, everything is a computation or a transform in some way, right? So we're trying to maybe characterize these into different things, although they share some commonalities. But in a transformation, I'm not doing just a computation of math. I might want to format something. I might have some source data that is a little loose in its definition, or several source datas from different vendors that formatted them slightly differently. And I want to normalize it into a canonical form so that I have more uniformity in the target. Phone numbers are an easy example. Other easy examples are numeric normalizations, such as rounding or adhering to a certain width. You had integers and bytes and you turn them into longs or decimals or whatever, either preserving or sometimes not completely preserving all of the richness. You might want to take phone numbers and strip away any extra characters. You might want to take phone numbers and add those parentheses and plus signs and things. It all depends on the spec. The spec, remember, I talked about it. We want to plan. We want to have some kind of useful inference on the other side. This specification is really what you're trying to fulfill. This specification is part of the planning, part of the the understanding before you put any strokes to keyboard. You want to understand what you're designing towards so that you can decide what transformations are necessary. Another, or the counter to normalize, is parsing, where you get data that in the source was a opaque piece of data type, let's say an address line, internally represents the street number, the street name, the city, the zip code, the state, things like that. And we want to separate them into individual fields so that I can say, give me all places in California or in Azusa or around a zip code or things like that. So this is parse. It's the opposite of normalize, but it's fairly straightforward. Another one is to combine. And here, when I combine, before I showed the computation that took a quantity and a price, multiplied them, a common transform would be to do a combination, first name, last name into full name, things like that, where I want to stringify several fields into one in order, again, to have a uniform picture on my target so that I can present it or further process it in a uniform way, glossing over, or I should say, regardless of how the source formatted it, my target format is more suitable for my useful inferences. And a variant on join would be, on a combine would be join, where instead of looking at a single source, a single table, a single CSV, or a table and a CSV I'm looking at, and I'm joining data together. So I'm taking entities that in the source were denormalized, were separate, but I'm creating a join as part of my transform in order to create a combined view that gives me my useful inference. So you might ask, hey, but my DBA is always saying, hey, denormalize everything. It should be denormalized, blah, blah, blah. Why are you forcing denormalization here? I'm not. What I'm doing here is I'm saying you want a useful inference. If it makes sense that those original entities, say the order entities and the user entities, remain separate in the target database, then I can do an identity transform, namely just copy them in. But more often than not, we have too many pieces of data in IoT projects, or we do not care to dig into the individual transactions that made up, say, a monthly summary, and we may combine them using joins and other things like that. And finally, we may find that joining or combining fields from a database or several databases is not enough. So here I'm calling out another variant, which is to enrich data. Enrichment takes, sure, some source data, but it takes another source of data that doesn't even exist in the source databases. It may not exist there because the sources don't care, or it's not their job to say specify zip codes or mail stops or things like that. It may be because the zip code data is actually a live service where I need to look up those zip codes and I don't have access to a full database of them because it's a paid service or something. And it may be that my transform is actually more than a single phase, in which case it's a little more like join. I bring in data from one source, then I bring in data from my lookup source, and then I join them all together. So this is why I characterize it a little differently. So if I have all of these under my belt, if I have all of those variants, it seems fairly straightforward that I can just start the project, right? I know what the tables are supposed to look like at the end, or documents, or whatever database technology you want. I know what source data I have and how it's format. I know how to clean it up. I know how to do some math on it. I know how to do joins. Yeah, what's the problem? Let's go, right? So one of the bigger challenges is that life ain't that pretty, almost never. Garbage handling. We will have to know when garbage comes at us from those sources, how do we deal with them? So sorting out the garbage and understanding what kind of garbage I might get and having a policy to how to deal with it is a crucial part of every ETL project. And garbage comes in a whole bunch of flavors. There are garbage that is technical. Um, Things like you read a CSV, but some of the bytes or characters in there are just garbage. They're some kind of Unicode or something. That can occur because of network transmission, I/O problems. You can have it also in relational databases or document databases, certainly wherever things came through a file or some foreign source, those can come in. So those are pieces of data that seemingly you have an integer and it says, oh, it's an integer. So how can it go wrong? Well, it went wrong because it overflowed, and now that number is meaningless. There could be lax data management on the source, things like the schema doesn't exist at all, or is missing, or hasn't been properly explained. So that kind is things where, say, you could have a CSV and it's comma delimited, but somebody didn't use quotes and there was a string that included the comma, so now it added a synthetic column. Or maybe some columns didn't arrive in and they're misaligned, things of that nature. It could also be that whoever created the source schema was very loose with it, created blobs in columns or things like that, and you now need to interpret it and understand it. And then there's the issue of somebody actually trying to fix the data for you ahead of time. Maybe not for you specifically for the ETL, maybe it came out of historical issues where they discovered they had garbage, and then they tried to put spackle over it. They basically washed over data that was dirty or bad and put in synthetic values that are not correct. And finally, there could be issues where there was good schema and a good attempt and or even justified schema decisions to keep things a certain way, and they mismatch between the source and the target. So let's say you expect that every product sold will have a SKU in the target database, but when you go to the vendor or to your shopping site and extract data from there, you find that you have invoices where there is the price of the product and there's a total sum that the client paid, but there isn't necessarily a SKU telling you exactly what the product that was sold is. So in those cases, there's a mismatch between the schema apparent in the source and your desired schema in the destination. So with respect to that desired schema, the source is garbage. It is not importable as is because you have non-null for the SKU, and now you get nulls for some of the products. So what do you do then? So here in the world of dealing with garbage, my approach would generally be to communicate way too much, to go to all of the people who are in charge or related to the source and talk to them, and to understand and talk to everybody on the destination side. Is it enough to just talk to the DBAs? Maybe. Usually they're very knowledgeable, but you might want to extend that to the people who are running reports, to the people who are actually reporting financials to understand what they do with the numbers. You might want to talk to the people on the vendor side to understand how data got in there. The more you can communicate and understand, the better off you're going to be and the better situated you'd be to deal with garbage and the various data conditions. So you're going to implement the ETL after extensive communication. And you should also expect that this experience is not a single point in time. The notion that you wrote ETL once and it runs for the next 10 years, good luck with that. You should expect that you need to continuously run through these three phases where you communicate, investigate, implement, and then rinse and repeat. Repeat that process again and again, because every new day brings in new data conditions. Maybe it's because the year is newer. So after a year, suddenly the range of years you're importing is larger. Maybe there's data deprecation issues. Maybe there's new vendors. Maybe there's new ways that the vendors treat their data that will make you need to deal with it in a different way. So now we're down to policy. Once we talk to them and we want to implement, we have to say, okay, what are we doing with the garbage? How do we deal with it? Let's take an example where I had a row and one of the columns in it contained garbage. Missing, misaligned, not correct for whatever reason. I call it garbage. It doesn't really matter why it's garbage. It's the fact that it's garbage. So one thing I can do for sure in my ETL policy is decide that if I see a row that doesn't match my final specification, I just ignore it. I skip it. That policy has implications, of course. If I do that, I'll have the side effect of missing data at the destination. Duh, Nuri, you skipped the data. Of course it's missing. How it shows up is maybe I have sales records to import, and now the total sales in the source amount to 100,000, and in my destination, I'm reporting less sales because I skipped data. Is that always a bad thing to skip data? Maybe. Maybe there's some data that statistically is not that significant, the number of clicks on a very popular web property or things like that, not financials. Maybe it's okay to miss a few. Maybe it's okay to miss a few IoT temperature readings because we don't expect that every 5 minutes a temperature changes by that much, and it's okay. In any event, if I do this policy, I will have to communicate. I will have to converse with the consumers of the data, and they will have to be aware that data is not always present, even if it was present in the source. Another idea would be to bring the row in, but skip that specific cells, that specific field within the source record. That also has ramifications. The side effects is that I just brought the data in the garbage into the destination. If I have garbage in the destination, then now everybody who consumes data at the destination will need to be aware of that. For example, if I did a query, let's say this was the SKU field of a product, the stock keeping unit identifier, and somebody at the destination ran a report that tries to join on that field. But guess what? There's no SKU. So if they did an inner join, they will net no product. So that means that some of the foreign keys relationships in the destination will now be broken. That means that my total sales will match, but my tie-in to other data sets or pieces of the entity may be broken. So doing that had its own side effects. And finally, we may try via the ETL process to fix the garbage, to make it into something that was not there in the source. So I'll just put a rubber ducky instead of the garbage can. So garbage we know stinks, it's not good. What's wrong with rubber ducky? So I claim the problem with fixing garbage on the fly is that it's still garbage. If I saw null and said, aha, I'll assign it the product generic something, or make some blanket decision that I can fill this, I know better than the source. If I made that, I made it up. And remember, our target is a useful inference. But now it is not inferred from the source of truth. It's inferred from Nuri's brain. That's hardly a solid ground to stand on. I mean, come on, I just made up data and now it's good data. Making up stuff is not likely to bring you good data. The other thing is, with that blanket decision, you either created the foreign key in the destination that never existed before, so you now invented new data and maybe oversold that generic product, even though all I sell was buggies. Now suddenly it's another product. Or it may break foreign key relationships in case that product doesn't really, that invented data doesn't really tie into anything useful. And a third type is magic numbers, where we see null and then the destination they say, no, this must be numeric and it can't be null. You have to put a number in, and people put magic numbers like -999. Aha, I know that you'll never sell a product for negative 999, so therefore it's a magic number. And those again create problems for all other reports that historically didn't have to care what's in this column because they knew that the product pricing was correct. And now that has some junk data, negative 999. So if you try to add it up, suddenly you deducted 999. And if not, now you have to fix all of your reports and filter out that 999. Well, if you do that, then why did I put 999? I just made everybody change a whole slew of code, which has huge cost implications. So this is back to design, right? We have to have this communication channel available with the owners of the source of truth, with the users of the useful inference, and have conversation on a field by field basis on what needs to be done. Questions so far?
Nothing currently.
Cool. Because now I have a psychedelic slide, so I wanted to pause for a second. I like tie-dye. I don't know. It kind of came together with identity crisis. I don't know if the joke transfers. Anyway, so identity crisis. So far, I've talked about the transformation themselves. Take a field, do some computation, move it over. How do I deal with it? What do I do? And that is data. That is actual data payload of the source records. The next thing I want to talk about is identity crisis, where the identification of records from the source, how do we carry it into the destination? Naive case number one, I have one vendor, he gave me some record, I have my farm wagon, its ID is 456, I just dutifully copy it. There's no need to change that ID, right? As long as the target allows numbers in that field, I'm good, I'm golden. Except if now I have another vendor, they might have a vendor's supplied ID that is the same between vendor A and vendor B, yet it refers to a completely different product. So now the notion that my target has just a single ID is problematic because there's a collision. Well, fine, you say, that's no biggie. I know that that number is unique for the scope of a single vendor. The vendor signs a paper that says, my vendor IDs are unique within my world. Good luck with that, by the way, but let's assume that's true. So what I can do is just add another field in the target, making the primary key, so to speak, of the entity a combination of two pieces of information. One, a vendor identifier, and the second, the vendor's own source ID. So this brings us to a discussion of surrogate versus natural keys in the destination. So a surrogate key is a key that is composed of one or more fields that uniquely identify the record. We already saw in this simple example that a single field didn't work. So in our case here, the surrogate key, a good surrogate key would be a combination of a vendor identifier, the name of the vendor, say, as long as that is also unique, and the source ID at the vendor. That's a surrogate key. Sorry, this is a natural key. I'm sorry, this is not a surrogate key. This is a natural key. It's natural because both fields that the key is composed of are actual data fields meaningful from the source. A surrogate key would be if I took those two fields, just shoved them into something in the destination, but added this ID field 147258. 147258 has no bearing whatsoever onto the data contained in the record. So that's why it's called surrogate. It's been slapped in. It has no meaning within that domain of that entity. It's just a foreign piece of data that got slapped in. So is it unique? Sure, I can make that unique. I can make it a ever incrementing number. I can make it a UUID. But if you just gave me the record, I would never be able to guess it. If you just gave me the vendor's original record, there's no way for me to apply a transform and generate that because it is completely foreign to the data itself. Sometimes you have something in the middle, right? Sometimes they say, aha, I'll be smart. I'll create seemingly a surrogate key, but it's not opaque. It's not just a random number. I'm combining the first three letters of the vendor plus the source ID number. Aha, I'm smart. I made myself a something that looks like a natural key, right? Because it has some meaning. I can parse this data in my brain and say it has some meaning. But I would say this is kind of like a surrogate key, because even though me in my brain I can parse it, I can't join on it, right? I can't, if I needed to do any kind of processing and understand what the ID is and what the vendor is, I will have to go to the real fields, not this combined combo field, which means to me this is really a surrogate key. Yeah, maybe easier for humans to read, but as far as a database engine is concerned, if I ever wanted to do anything useful with it, I would need them separated. I would need the DTN to become Dayton and the 456 to be separate. So it's not useful on its own. It's opaque. It looks a little sexier, but it's not really a great help. So if you ask me which one I should choose, I would tend to say the surrogate key. And the reason for that is it's very repeatable. And sorry, not sorry, again. If you ask me what I would do, the one with the metal here is the natural key. And the reason for that is that the data is meaningful in the source of truth. That natural key is natural. It is a natural part of the data. It reduces the amount of joins I have to do. If you see this record here with a vendor Dayton, I can say, query me all products with a vendor Dayton. And furthermore, if I wanted to re-import, I could completely nuke out of existence the target database, remove all of my auto increment seeds and everything, whatever, crutch I was using to generate IDs. And I will still have a very good primary key because a combination of these two fields is unique. It is a natural key. That is what natural means. On the counter, if I wanted to create a surrogate key on the target, I will need to forever maintain extra state to do it. Sure, it could be a UUID, but if I deleted that target record and then I try to re-import the same original record, I will end up with a new UUID. Well, that can break a lot of relationships because it's not natural. It doesn't belong to the original source of truth, which is why natural keys really rule. They do have the side effect of making some queries require extra lines of syntax, but they are a very good fit for entity modeling and querying. On the other hand, and despite my preferences, many shops in reality use a surrogate key. And if your boss says, use a surrogate key, but I don't like it, and what about the thing and the that, and if you lost it, how would you regenerate it? Yeah, use a surrogate key. So if that's what they insist and otherwise you're fired, then use surrogate keys. I see this approach done a lot. Sometimes it's done for the reason that people deem those surrogate keys to be faster for join. They neglect to tell you that once you use natural keys, you don't need as many joins, but that still is a very common practice. Questions, natural surrogate keys?
So I don't see any questions about that, but there's one other one that I can read real quick. So someone asked, and I'll just read this. Sometimes ETL tools can make it harder to unit test and are sometimes also tricky to do integration tests with. Are there any that you've worked with that are better than others in this regard? And are there any specific or useful techniques that you found for testing and validating ETL processes?
Yeah, so, great question, first of all. And I do have a little discussion of this, but I'll, since it's been asked now, I'll say completely agreed. It's one of the reasons why I don't like the fourth and fifth generation tools that have you click around a screen and type in little things. All of those visual UI things that remove you from the code itself tend to be problematic because it's very difficult to unit test, even if the source, even if the product of the ETL process you describe by clicking around the screen becomes a file that you can check into source control, no human can read that. So that makes it very difficult to test, and you end up with things like, well, how do you know it's working? Oh, well, I ran it in the dev and, I looked at some records and it seems okay. Seems okay. So to me, seems okay is like, no, you're fired. Go do it again. Like you want it repeatable. So you ask me what kind of tools allow you to do this. To me, and especially with a background in code, I am more prone to use frameworks that allow you to express the transforms as code, things like Airflow. And when you do that, you get to just write little modules. Each module is a pure code function. And being a pure code function, you can unit test it. You can further go higher up the stack by doing an integration test by passing through it data from certain places. So you want to abstract your source and destination connection strings and so forth so that you can run the same process as a build, that you take that build, put it in an environment, run it through, and then create an expectation using unit testing or other kind of frameworks. So that's as close as I would get to doing a more CI/CD oriented process. The antithesis for this is tools that generate miles of XML or JSON, doesn't matter. That's just not humanly readable. That is just a mesh of lines going from here to there and everything, no documentation. That's typically where you get in the enterprise people who are married to the job, who have job security, because understanding this stuff is just beyond anybody's single brain cell. So anyway, I hope I answered that.
Cool. Yeah. And actually, just real quick, someone else chimed in with one that's related to this slide before we move on, asking, don't you have to repeat the natural key in every join table, like order detail and things like that?
You did, but then you have the data included there, which means that if you wanted to query that, you already have that piece of information embedded in that order. So now, say my line item detail already includes not only the SKU, but also the vendor ID. But the vendor ID is just the vendor name. So if I wanted to pull invoices by and group them by vendor, it's already there. I don't have to join back to vendor to get vendor ID from vendor, to get the vendor name from the vendor ID. Or let's say instead of having a country ID, I just had the country code or the country itself. I don't have to go to a country table to do a join. on some number, number 1 is US, number 2 is Canada, I don't have to join anything. It's already USA, it's already Canada. So natural keys bring within them some data from the source of truth, and many times reduce the number of joins you have to do. So on the one hand, it's true, you'll have to say on table A, join table B on A dot X equals B dot X and A dot Y equals B dot Y. On the other hand, you'll need less joins like that. So yeah, there is some syntax complexity addition, and I wouldn't say complexity, but syntax busyness addition that you get from it. But you do get the properties of embedded data that reduces the number of joins you have to do. Something else in the chat, or okay?
Yeah, it looks like just one follow-up comment from the same attendee saying he wasn't really thinking about joins specifically, more of the extra columns that occupy space in every table by repetition.
Yeah, so there is a space implication. However, and for the similar reason, because this data is natural, it is part of the original record, you actually get to not do joins later. And think about it this way. If your queries were all joinless, you would basically be querying a single row and it had all the data in it. It's faster than doing a join. So yeah, data on disk is rather cheap. Data in memory is expensive. And CPU cycles are almost free relative to that. So you balance, you balance space, but data on disk is rather cheap. Once you have a proper indexing and natural key data, the number of joins you'll have to do is reduced. So the actual workload, the runtime workload, should be lower in many cases. Not all of them, but in many cases. So I was talking about Apache Airflow. If someone was asking about a tool in unit test, so it's not a link to unit test, but if you read the documentation of Apache Airflow and you see how it works, you will very quickly understand how easy it is to represent ETLs as code, and that code using your regular coding practices can be CI/CD'd. Okay, I'm going to move on a bit, and we'll have more time for more questions too, if it's okay. So we looked very closely at field per field kind of mutations, changes of the ETL. That's the T, the transform. But taking a few steps back, let's look at what kind of changes will I have day after day when I need to keep my source and target up to date, my source I'm not responsible for as an ETL person. So what kind of mutations happen to data as a whole, right? Well, I have the creation, namely yesterday I had no data and today, boom, I have a new record. I have a record that existed yesterday, but today is different. And I have a record that existed yesterday and today does not exist whatsoever. So how can I represent, or how can I process these types of changes to source data? The easiest is get one of them their flamethrowers. If you just take a full reload approach, a scorched earth approach, just nuke the destination completely. Every time you run your ETL, just clean up the target, nuke it out of existence, and then just apply everything you see today. If you do that, you should end up with a good picture of what you see today from the vendor, right? It's not always feasible, of course. For one, the size of the data might be prohibitive. Maybe I have just an hour a night to perform everything, and loading the data takes too long if I want to reload everything. It might cost a lot in terms of juggling data over the wire, especially in cloud environments. It might cost a lot in terms of CPU and resource intensive processes, which harkens on the time, but basically requires just way more resource to process. So it might not fit speed-wise, might not be a good process. And of course, it works when you have a single vendor, a single source, and a single target. But if you're going to nuke the target table or collection or what have you, you basically lost all of the keys for that duration. You made this target unavailable for that duration, as well as you broke all relationships, if any existed. So for that reason, scorched earth is not, I would say, always preferable. For small data sets, certainly it can work, but for larger, more complex data warehouses, it's rarely tenable. In addition to breaking relationships, as I said, some data may not exist yesterday, doesn't exist today. Well, if it existed yesterday and it was in the target database, somebody ran a report and had it. And now if they're going to rerun the same exact report, that is going to seemingly disappear. So that creates some kind of a logical problem. The fix for that is fairly straightforward. Most of the ETL process I've seen exercise some manner of this. It's an upsert. If the record from the source exists in the does not exist in the destination, you insert, you create it anew. And if it exists in the destination, you slam the field values with the new field values that you just transformed into. So that is very common. Number one here shows a record never existed in the source. We're just going to copy that over. Number two here shows a record that existed in the destination. So now we just have to update the value. Maybe it was 40, we added $20 and now it's 60. Maybe we changed our ETL and we're not really talking about data that changed in the source. We're talking about ETL resulting in a different computation that makes the data in the destination change. Either way, we just update it. And then finally, we have data that changed in the source and therefore needs to change in the destination without change to the ETL. So 2 and 3, imagine that under both of them, we just added 50% of the price, and that's kind of does the trick. So one thing I do want to mention here is in the early slides I showed source to target destination that go one way from the source to the destination. There is sometimes a tendency in scenarios where we say, aha, just take the price that we had yesterday and add one to it. So in that case, it's a scenario where not only do you consider the source database, but you consider the current value found in the destination. That I call sourdough. I didn't invent this term. Some people call it, I learned it from somewhere, so it's a subset of the population uses that. The problem with sourdough, like sourdough builds, is that they're not repeatable. And not repeatable is the enemy of true. Not repeatable means that if I were to replay that transformation, now I will get an incorrect value if I repeated the transformation, I will end up with bad values in the target. I want my ETL to be idempotent. If I run the ETL on the same data set in the source, I want it to result as a certain snapshot, a certain image in the destination. And if I run it again on the same set, I want to end up with the exact same image. If I had to refrain, if my ETL is such that I can only run it once, but if I run it twice, it will mess up my data, it will double my sales, it will do horrible things like that, then it's not idempotent. And things that are not idempotent, that's sourdough sometimes because it takes data from existing values. Sometimes it's just bad computation. But those are very dangerous, and I try to refrain from doing that in any way I can. So to detect a deletion in the source, I have essentially like two grand ways of doing that. The first is using source log, and the second is manual scrub. And that deletion detection actually goes to change detection as well. So I guess I should rename this slide to change detection. Using the source log is the idea that the source engine, be it SQL Server where with its log, Oracle with its redo log, MongoDB with its uplog, systems that maintain a serialized list of every mutation happening at the source database. If you have database infrastructure that supports that, great. That means you can tell what changed from yesterday to today by just looking at that log, setting off your cutoff to the last time you ran your ETL process, an hour ago, a day ago, doesn't really matter. As long as the information is there in the source, I can go back in history lane and say, aha, I processed up to here. Now all I have to do is read all of those changes and apply them to the destination. Yay, that's easy. So if you have that kind of system, great. Sometimes you don't have an engine that supports it, or you have a source engine that doesn't guarantee you have a long enough time window that it maintains of those operations. So let's say if your redo log or your log in the source only contains 1 day's worth and you run your ETL once weekly, obviously you would be missing 6 days of changes. So that's untenable. So either way, there are reasons why that is not feasible, in which case you go into manual scrub. So in manual scrub, what we do is we load the data from the source as it is today, and then we perform set math, basically take the data set in the target database, compare it using a join, a full outer join, or what have you, to the current image. And after doing that relational math, we can figure out really easily, right? Things that existed in the source but not in the destination, they're probably new. Things that existed in the destination but not source, they got deleted. In things where the identity matches, compound identity or via surrogate key, easier by the compound natural key because that is part of the record, of course. So things that exist on both sides and match up, but don't match up all the values, we just need to slam the new values in. So that is manual scrub. So which one is cheaper to perform processing wise? Probably the one of the left, if you can swing it. And which one is more expensive, but absolutely traceable, repeatable, and human inspectable? The one on the right, because it's easier to do the math from a logical perspective. Mechanically, it could be huge. It could have terabytes of information. Those joins may run forever. So you might need even an intermediary data store, but it is a very solid way to detect changes. And definitely the results are very accurate. So we detected some deletion, we detected some changes we need to do, and now we need to decide what to do with deleted rows. If we take data that was deleted from the vendor, we detected it was deleted, and we delete it in the target, then we're going to break some foreign keys. We're going to break yesterday's reports. If we do nothing, we basically ignore the fact that that data is no longer in existence in a source and keep it in the destination as it was yesterday, that data becomes stale. It is no longer represented in the source, so it's no longer part of the source of truth. So I infer that it was like that at some point, the last time it was loaded, but from now on, with respect to the actual truth, it becomes stale as the day grows long. And finally, there's a hybrid approach, which says, well, note that it was deleted and add a little column that says deleted on certain date, or move it to an archive or something like that. So either way, whatever policy you choose, you have to think about the consumers of the data. You will have to think about what are they using it for? What is their useful inference? And you will have to communicate that in case of deletions, we have this. So just before, somebody was concerned that natural keys create for wider data rows more data. Well, guess what? If we're doing marking the target with deleted or adding an archive table or stuff like that, we're adding to the storage needs as well. Not only that, we have to add into every query, both in the no-op and the mark target policies, we have to add to every query some clause that understands to either skip or include these deleted records. So nothing here is free. It's all about communication and deciding on a policy and educating the clients, or the clients educating you on the expected use and fitting your ETL to produce that useful inference. So the cat's a little out of the bag on this one, still missing something, right? We missed design in the beginning. But what needs to wrap this up and round up this whole thing is quality. And quality, I already discussed to some degree, prompted by the question, is something we want to really, I would like to see the whole world of ETL moving away from UI tools, moving away from kind of passive description of ETL processes in the form of XML files and JSON files and all of this kind of implicit transformations. I, as a programmer, like imperative programming. I like code that does something. I like to perform functions that are repeatable, that are testable, that are check-inable, maintainable in a source control system. So here, my best advice is to try to modernize away from systems that hid all of this goodness that we know about software deployment practices. It's ugly when we have to eyeball our ETL process that we just clicked on a giant screen with all kinds of lines going from one to another and just magically type some stuff. Eyeballing the data does not amount to unit testing, does not amount to asserting that it will run correctly. Eyeballing is a human thing. I want it written. So if I eyeballed it and it looks good, tomorrow I get run over by a bus, somebody can come in and say, I know how to eyeball it. How's that going to happen? So it's better to have ETL's functions as code checked into source control. It is better to have automated CI/CD that does unit testing on the individual transformation, as well as is capable of running integration tests by running the whole packaged code as a unit in an environment where you have a known source and you can observe the parts of the destination, run queries and say, yes, as long as I migrate this source using this ETL, and these are the destination values, I know it's good. That's repeatable. I can get run over by a bus. Please don't run me over by a bus if you're a bus driver, but you get the picture. You want to make yourself replaceable. If you are, believe me, you will not be replaced. um, People who think that they can maintain their little fiefdom by doing some magic transformation find themselves more and more isolated because nobody can understand what they do. And eventually somebody wants to replace that because that's not scalable and that's not safe for the organization. So with that, this is me. I guess I have a slide here. I'm going to grab these and, oops, sorry. I'm going to try and grab these links and put them into the chat. But if there's more questions, comments, concerns, discussions.
No current questions right now. I would definitely encourage folks, if you have anything sort of on your mind, drop it into the Q&A or the chat before we close things up. I guess I'll seed it with one quick question of, I'd be interested to know a little bit about if you have any experience on the more streaming side of ETL. That's kind of been a lot of the direction that a lot of organizations are moving in, of trying to do this more real time instead of daily or hourly batches and stuff like this.
Did Ami put you up to it? So my problem with streaming is, so the idea, first of all, what is streaming? So streaming is the idea that instead of my source database being a snapshot static bunch of data that I take in bulk, I take records one at a time or 10 at a time, doesn't matter. But I take them out of a fire hose and I continue with them. So one prime example would be, say, a Kafka. Let's say somebody decided to airdrop all of the data from certain sources into Kafka, and then I consume it as a Kafka stream. And the idea there is that instead of once a day running an ETL, I'll just narrow the time window and I'll pretend that I just get a set of changes already handed to me from the stream. And I'll just run a transform on the single record at a time, or 10, doesn't matter, right? So I'm just going to run at the tip of that and continuously update my database. So my current sentiment on this, I'm trying to make it less of an assertion and more of where I'm current at. My feeling about this as of right now is that that's not ETL, because it took away the core approach I took, which is I have a source of truth, right? At a certain point, I can observe the whole source of truth, and I have useful inference that the ETL process is responsible to generate. I cannot look at a stream and say, this is my whole source of truth. And indeed, in that source, there may be a record, a single record that is rapidly changing. I may get airdrop like every 5 minutes, they update the total sales or total clicks on a thing, and I get a record for the same property that now it's 10 clicks, it's 15 clicks, it's 20 clicks, it's 20,000 clicks. I never have an image of what the whole context is of that. So I don't like to think of it, therefore, as a source database. Is streaming useful? Sure, absolutely. But is that really an ETL process? I don't know. I don't like to think of it as that. I also don't like the idea that my target is constantly changing. Because if I run a report for today, I don't want to change it, have to change it every 5 seconds. That's what was called dashboards. Who is it useful for? Like, is Wall Street going to say, oh, wait a minute, Nuri has an update to the pricing. Oh, another update. Oh, I clicked a button. It's like, it's meaningless. Especially in bigger data warehouses. Yeah, you can stream stuff in, but we want stable reports. To me, that makes much more sense. Might not be popular. I don't know. Persuade me otherwise. I don't know.
Yeah, I was just curious for an opinion, that's all. We do have one other question here that came in as well, wondering if you have any anything coming out maybe for Pluralsight in the near future around creating CI/CD pipelines in Azure DevOps for ETL.
That's a great idea for a course. I don't have one
Maybe the
planned
answer
or
now is
commissioned.
yes.
That's a, yeah, that's a great idea for a course. Yeah. So the answer is no, I don't have one right now, and it's a great idea. What one one of the things I did observe is that advisory around doing ETL becomes so data data source or data destination specific, and we kind of tend to lose the human aspects of planning and the understanding of the fundamentals of understanding your source of truth and understanding what the truth they have is and how they represent it. And so one of the things that's interesting to me is the data contract on the destination, and how can we make those data dictionaries, data catalogs more transparent and more reliable, such that we can support that consumers of those useful inferences, and they do not have to get a degree in SQLology or something in order to do their job. You know, that I I I see so many issues arising from that, and there's some famous issues where some analyst took data from what was supposed to be useful inferences and made up their own inference, which cost some people a lot of money and some people their jobs. So I think that's the area of innovation that was occupying my mind. But yeah, what's the name of the course I need to do now? Yeah.
Oh, and just as I was about to say, there's no more questions. We just had one more come in. So in the context of data batch size, or is concerned for ETL processes, would that be designated somewhat in the design phase of ETL, considering operational constraints relative to throughput?
Oh, absolutely. So, in the, yeah, so absolutely. That is why we plan, right? We wanted to be in a space where we were looking at the process, we're doing our design of the source of truth and figuring out not only what is the data, what are the fields, what should they look like in the destination. We want to do some metrics, some real measurements of how long it's going to take me. We want to estimate what resource do I need, median bastion server computer or some big infrastructure in order to process it, maybe an EKS cluster, I don't know. So we want to also come up with estimates of how are we going to produce it and how much it's going to cost us in terms of labor, in terms of money, licensing, what have you. So that is absolutely part of planning. You have to consider what is the time window you have to perform those ETLs. I know streaming is like right now, right? But what is the time window and how do I fit in it? And that may affect your decisions on the techniques. But it should really affect your technique decisions, not your principal decisions, which is why I was harping so much on doing the right thing. You have a choice, right? You can skip a row, you can fix the garbage, you can pretend it didn't exist, you can spackle it. So those are all value decisions, and you have to make a strong judgment there. The technology decisions, although impactful, by all, with all due respect, I think are secondary. Namely, once you came up with the right approach and the right prescription, you should be able to sell it to your boss and say, this brings you the quality you want. Because if it's of no quality, it has no business being created. If it's not a useful inference that somebody can take to the bank, take to Wall Street, report data from, run the business correctly, then it's junk, it's garbage. And if making stuff not garbage costs $1 or $10 million, whatever it costs, it costs. So you can optimize in things, but first drive quality, I would say.
Cool. So it looks like that's about all the questions that we have so far, unless another one pops in just as I'm starting to say that again. But given that we're coming up on it's like 8 o'clock Pacific here, I'm not sure where everyone else on the line is from. It seems like a really good place to close things off. So Nuri, just want to say thank you once more. Like, this is a lot of really fantastic content. Really appreciate you sticking around and going through this with us.
Yeah, thanks a lot for hosting me, and thanks for the good questions. I guess we can take chats offline, and see you all at DataCon or IRL when this whole COVID thing's over.
Yeah, and thanks again to everyone for hanging out. Really appreciate everyone sticking around and especially asking questions. As from an organizer's side, it's really awesome to see folks engaged and learning a lot from these. So really appreciate everyone sticking around. Hopefully we'll see you in a couple weeks for our next meeting. Keep an eye on all the usual channels for when the video of this will be available. Should be probably sometime later this week. But in the meantime, have an awesome night. Stay safe, stay healthy, and we'll see you soon. Have a great night, folks.